Hi students and welcome to T-Rex Math. Today we'll be reviewing angle sums of any polygon. Our focus question is, what is the angle sum of any polygon with n sides? So remember from 6th grade that the variable n stands for any number of sides that any polygon might have. So yesterday we looked over here at this triangle. And it's different from the triangle that we studied before because it has sides that are different lengths. So it would be considered an irregular polygon. So when we tore off the angles yesterday, we noticed that if we add the three angles together, we get a straight line. That straight line would be 180 degrees, which again proves that the angles of a triangle, even though it can be irregular, add up to 180. The figure on the bottom, our quadrilateral, we also know is irregular. And because it's irregular, we wanted to test the same idea. So by tearing each of the angles off of the corner and putting the four angles together, we noticed that the four angles add up to a full circle, which makes 360 degrees. So to confirm, we just want to be sure that we have an understanding of the difference between a regular polygon and an irregular polygon. So make sure you have these ideas in your notebook. A regular polygon has equal side lengths and equal angles. An irregular polygon, on the other hand, has different side lengths and different angle measures. So to add on to that, you'll want to make sure that you have these two definitions in your math notebook clearly written. Even though a polygon is irregular, it's still, depending on the type of polygon it is, will have an angle sum that's equal to a regular polygon that is that type as well. So to clarify, even if I have a quadrilateral that's a regular quadrilateral, like a rectangle, versus the quadrilateral pictured here that's irregular, even though we have a regular versus an irregular polygon that's a quadrilateral, both will add up to a sum of 360 degrees when you add up all the interior angles. Okay, yesterday we learned that tearing the corners off of an irregular polygon is a great method to figure out the amount of degrees in the inside angles. Sometimes that can be a little bit cumbersome, and it might be easier to use another method where we take each of the irregular polygons and draw an endpoint at each vertice, like I did in the pentagon. From one of the vertices, you can draw a line segment across the irregular polygon without having any intersecting lines. Okay, from there we notice a pentagon with 5 sides can be divided into 3 irregular triangles. And since each triangle is 180 degrees, 3 triangles would be 540 degrees. We use that same method on our quadrilateral. Take each vertex, put an endpoint, choose one of those vertices, draw a line segment across without intersecting any other line segments. Get 2 triangles. So in this case we have a quadrilateral, a 4-sided figure. It's irregular. 2 triangles. Each triangle is 180 degrees for a total angle sum of 360 degrees. Lastly, we take an irregular hexagon. We know that a hexagon has 6 sides. In this case, they're all different side lengths. We make an endpoint at each vertex, draw a diagonal line across from one vertex to the other, count the number of triangles. So in this case, hexagon, 6 sides, 4 triangles. Each triangle has a value of 180. So the total angle sum would be 720 degrees. So hopefully you're starting to see a pattern here between the number of sides in the polygon and the number of triangles created. Once we kind of have developed that pattern, we can apply that pattern to any polygon no matter how many sides it has. All right, yay, now it's your turn. Pause this video, draw an irregular octagon, divide it into triangles stemming from one vertex. Remember, no intersecting lines. Find the total sum of the angles inside the irregular octagon, and then check your work on the next slide. All right, time to check and see how you did. Now remember, your octagon is not going to look exactly like mine because it's irregular. The side lengths are all different and the angle measures are all different, but you should have 8 sides and 8 vertices, even though it's irregular. So let's see if I've got 8 here. So 1, 2, 3, 4, 5, 6. Okay, so there's 8 there. Then you choose one of them. So check to see that you've done that. I'm going to choose the bottom left here, and you're going to divide your irregular octagon into triangles. You're going to count up the triangles that you have. And hopefully by now you're seeing that pattern. So there's 6 triangles, and each triangle has a degree of 180. So 6 multiplied by 180 is 1080 degrees. So the angles add up to 1080 degrees.